Hey everybody, Mrs. Slauson as always, and I am on page 24 in your note packet. So the last video that you saw in week 4 had me graphing linear functions with these restricted domains. I didn't graph the whole line, I only graphed part of it, and I also graphed absolute value. So it's with that knowledge, it's having you watched those videos that I'm going to be going into the week 5 videos, which is graphing piecewise functions, okay? So again, I'm on page 24. We're going to be covering page 24 and 25, and it's kind of just going to piggyback on what we've done so far. All right, so this is a great time to use a pencil and not a pen in case we need to do some erasing. I guess it just kind of depends how you want to set that up. So I'm looking for a pencil. Mine's not very sharp, so give me one moment. I'll grab one. All right, so got my pencil. Okay, so again, I'm on page 24. So a piecewise function was mentioned before. It's where we have a function, but instead of the whole thing, I'm just going to have a little piece of it, all right? And when I see you in class, I got a little video to watch. It's super funny, but I won't show that to you now because you're going to watch my video. All right, so how do you graph a piecewise function? So first, you want to determine the domains for each piece of your piecewise function. So the boundary walls, that's where I told you that story, you know, x or as y flies by, so y equaling a number goes like this, and then x is depressed. So x being a number, which is over here, x is 2, -2, goes like this, all right? So what I'm going to do first is just take this problem, and this side of the comma, let me draw a little wall, is my boundary wall. So ignore the inequality for now. I need to draw a line at x is 2. So I go to where x is 2, and I'm just going to draw this vertical line through it, because every point on this line, this is the x is depressed, every point on this line has an x value of 2, while the y value is changing. So that's why, again, it gets the name x is 2, because this is 210, this is 27, this is 23, this is 2, -5, all those x's are 2. So what I'm going to do is I'm going to graph this line to the left of it. See how it's pointing to the left? That means less than 2. And I'm going to graph this line to the right of it, and I'm going to use my pencil. So the biggest challenge is when people graph this, sometimes they look at this as the y-axis, so I really want this to stand out. I do not want to graph on that line. That's not where I put my y-intercept. So I'm just going to start with this one. And again, this is a line, so my y-intercept is b. I'm going to begin at -1, and my slope is -2, my rise over run, which means it'll go downhill. So remember, don't go here and begin at -1. This is your y-axis. So I'm going to begin at -1, and I'm just going to graph the whole line. I'm not going to worry about anything else. And I'm going to rise 2 and go over 1. So if I rise 2 to get that downhill look, I need to go to the left. And I'm just going to keep that pattern up. And then I'm going to go to the right and just, again, keep it up. So let's say you're just graphing the whole thing like Miss Lawson says to do. I'm making dots. I'm filling up the whole piece of little section of graph. So normally I would graph this whole line, but this says I only want the line that's less than 2. So this part won't be needed. So I could actually erase those dots or never put those dots. Instead, I want this part. And try to draw it as straight as you can. And remember, even though my graph paper is ending, it doesn't mean my line's ending. So I want to make sure I put an arrow. So the other thing I want to do is to decide, you know, when I have this dot here, do I want to leave it an open circle or a closed circle? And so when things are underlined, you want to include the value. So I want to make a really big noticeable closed dot. So when I'm talking about who does 2 belong to, when I get these 2 lines, 2 is going to belong to this line, all right? So now I'm going to graph the other line. So again, on this one, I will be beginning at 4, and then my slope is a -1. There's a 1 in front of it, and I have a rise over run, and again, this is a negative slope. So remember, I want to begin here. Don't begin here. That is the biggest mistake. People put -1 here. We're actually going to begin, 4. We're going to not begin at 4 here. We're going to begin at 4 here. So I'm going to put a little dot, and then I need to get a negative slope. So I'm going to start to go up 1, over 1, up 1, over 1, And, you know, you can keep this pattern up. Again, I'm not going to connect these points. And then I'm going to go to the right. I'm first just drawing the full line. Eventually, you really don't want to do this, but this is the beginning step. So I would normally have this whole line, but because of this domain restriction, I only want the side of the line, or the part of the line that's bigger than this wall, to the right of this boundary wall. So I'm going to go from here to here, and then I'm just going to go and erase these points. So that's why it's a good idea to use a pencil. Now, if you're going to use a pen, some of you, then, you know, get your trusty white out and white out those points, okay? Or just connect the points that you need, like that, all right? Now, I'm not going to include two, so I could do one of two things. This is a really noticeable dot, so I don't have to put a dot here, or I could just kind of make it more open. If you don't see a really noticeable dot, then that is implied as an open dot. I hope that makes sense, all right? Okay. Let's go ahead and finish this graph, and let's go ahead down here and answer this stuff. So first, I'm going to have 3 lines, -4, x minus 2, and 2x plus 4. And I'm going to have 2 boundary walls. So again, let's just kind of separate this out. I'm going to have a boundary wall at -2. So here goes my -2. So this will be graphed left of -2. This one will be graphed in between. That's what that means, -2 and 2. So now I'm going to add 2. And then this line will be graphed to the right, or where it's bigger than 2. And again, if you want to take a highlighter to really make those stand out, feel free. All right. So let's actually start with this one, because I'm going to describe that one last. So this line will be just over here. So now what I'm going to try to do is only graph what I really need. So on this line, I should begin at 4, and my slope is a -2, and it will be going downhill. So remember, don't start at 4 here or 4 here. You always start at the y-axis. But remember, this line is only going to be over here. So let me actually erase this and put it elsewhere. So in this section, I'll be putting the line -2x plus 4. All right? In this section, I'll be putting, I'm going to erase this line now too. I'll be putting x minus 2. And then over here, I'll just be putting the line -4. So that's kind of a reminder of what's going to go where. So again, back to this one, I'm going to begin at 4. My slope is a -2 over 1, which is going downhill. So I'm going to start here at 4. But remember, I only need it here. So I'm just going to kind of keep track of my points. So I could go up 2 and then to the left to get this downhill look. So let me lightly put these points. But I don't need it in here. So I'm not going to go up 2 and over 1. Instead, from here, I'll just start to go down 2 over 1. Don't really need the point, so I'm not going to dot it. But if you want to put it there, you can erase it later. Down 2, and then this is where I start to need a point, over 1, on this line. Down 2 over 1, down 2 over 1, and I'm going to fill this graph paper all the way up. And then I'm going to connect. So now I want to check, do I want this 2 to be part of it or not? And since it's underlined here, I will put a really big noticeable dot. All right? So now I'm going to graph this one. So I'm going to erase this part, because I'm just going to kind of reuse it, and describe this line. So this line, I should begin at -2. And then the number in front of the x is 1, or 1 over 1, and that's positive, so it's going to go uphill. So here, I actually want to be in here. So I'm going to make a dot for when I begin at -2, a point. And then I'm going to go up 1 and to the right 1 to get that uphill look. Up 1, right 1. And I land on this. If I keep going, I'm in an area that I don't need to be. So I'm going to keep finishing this to the left until I hit this wall. So down 1, over 1, down 1, over 1. And I go like this, okay? Now we're going to talk about, well, how do you know where this dot goes to? Does it belong to this one or this one? And in the picture, you can't tell, but you can tell up here, and we'll deal with that, you know, kind of when we get to over here. All right, now I'm going to graph this line. So remember, f of x is y, so this is just y equals -4. And remember, when it's just y as a number, y flies by, and x is depressed. So what I want to do is go to where y is -4 and draw a horizontal line like this. Now, I could keep drawing it, but, excuse me, I might sneeze here. I don't need that part. And the reason why this is called y is negative 4 is because every y value on this point is negative 4. So this is negative 3, negative 4. This is negative 6, negative 4. And this point is negative 8, negative 4. So all those y values are consistently negative 4. So now I'm going to decide when I go to my wall of negative 2, do I want a solid dot or an open dot, a closed dot or an open dot? And because it's underlined, I'm going to make it a really closed dot. So again, it's kind of hard to tell, who does the closed dot belong to, this section or this section? And for the picture, we're not going to worry about it, all right? And by the way, I'm putting an arrow because even though my graph paper ends, my line doesn't end. So let's go through and talk about these. So what is the x-intercept? Well, it's where it hits the x-axis. I'm just going to fill in some of these points. So that is 2, 0. Where's the y-intercept? That's here. So that's 0, negative 2. I want to talk about where the graph is increasing. So let me get a little marker. This is increasing, right? And let me mark these important points because now they're starting to pop up. So I mark my ends. So this arrow is going to the left, negative infinity, but it's not going up or down. It's actually always staying consistently at negative 4. So I'm going to put a negative 4 here. Here's a turning point. That is negative 2. Negative 4. Again, always mark your graph. All right. Here's another turning point, 2, 0. And then I have this arrow. So this arrow is going to the right, so infinity, and it's going down, so negative infinity. So when I do my increasing, again, we're describing that y is increasing, but we're going to use our x values. So from negative 2 to 2. And still, with increasing and decreasing, we never underline those. Oops, sorry. Ignore that. That's my Algebra 1 format. Oops. White out. We're doing this, parentheses, negative 2 to 2. Decreasing. So I got a decreasing stretch here. Let me just put that in pink. Something like that. And it starts to decrease at 2 and goes to infinity. So if you notice, every section is just building off of the next section. Positive. So this is where the y's are positive. So that's above the x-axis. And I actually don't have anything. So I'm just going to do this. Don't leave it blank. Mark that you realize that there is no answer to that one. And negative. Well, it's negative the whole time. It's negative from negative infinity. And actually, I take that back. It's not the whole time. Because here the y values are negative, 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 until I get to here. And then it stops being negative. So I'm going to put one description from here, from negative infinity until I get to 2. Because at 2, it stops being positive or negative. It's neutral. And then it has another negative stretch from 2 to infinity. So again, I want to do 2 separate ones because at here, this is not positive or negative. So I got to think of it as one stretch and another stretch. All right, let's do this one. So when x is negative 5, so you got 2 ways to do this. One is I could go to my graph where an x is negative 5, and I could go down here and be like, oh, yeah, that y is negative 4. Or I could see where does negative 5 fit in here. So negative 5, as it turns out, is less than negative 2. And no matter what, the answer will always be negative 4. So you can look at the picture, you can look at the graph, and you will actually get the exact same accurate answer. Now, when I do 2, I've got a problem. So if I look at my graph and I go to where x is 2, sometimes it's not going to be at the same point. So what I really want to do, because one of these could actually be a little bit higher up. So here it's not. They're at the same point. So either way, if x is 2, I've got y is 0. But if you couldn't tell, I go up here and I want to use the one where 2 is included, which is in this one because it's underlined. And I could take the value of 2, put it in here, and do the math. So what I'm saying is I could do negative 2 times 2, add the 4. That's the equation I'm using. So I get negative 4, I add 4, and I get 0. So sometimes the picture's okay, but don't use the picture unless it's 100% accurate. So here it's accurate. I really didn't need to use the equations. All right, let's go to this one. So I'm going to mark my important points. So let's start with our arrow here. It's going left, and it's going up. let's see. I don't know what the x-intercept is exactly, so we're going to pause there. It ends here at, let's see, this is 2, -5. That's an important point. This point, it starts, and that's at 2, 2. This x-intercept, I know exactly. It's 4, 0. I can tell that because I got a dot right on there. And then this arrow is going right, and it's going down. So let's talk about this one. I am not quite sure what it is. This is an x-intercept, and this x-intercept belongs? Yeah, to this equation. So remember, all x-intercepts are when y are 0. So I'm going to take the f of x. I'm going to do a little math here, and then I'll write my answer. And I'll make y 0 for the -2x minus 1. So I'm going to figure out what number, if I put in for x and do the math, will make my y 0. So I'm going to add 1, and then I'm going to divide by -2, and as it turns out, that x-intercept is -0.5. All right? So I'm going to mark that important point, -0.5, and you can do a decimal, that's fine, 0. All right, let's put our x-intercepts down. So one x-intercept is -1/2, 0. I had to do math for that one. The other one is 4, 0. I didn't have to do any math for that one. And it's an x-intercept, so it's a point. I write it as a coordinate. My y-intercept, I can easily tell my y-intercept because that was an exact dot that I put on there. That's 0, -1. Where is the graph decreasing? So again, we always look at a graph left to right. So I know this arrow is pointing up, but from left to right, it's decreasing. And then it has another decreasing. So it starts the decreasing from -∞ to 2. And then it picks it up again at 2 and goes to infinity. So if you notice, these kind of, sorry, this is getting stopped and you can't see the paper. What you could do is, if you want, you could make this one big problem, but I think it is actually better to leave it separate because it stops decreasing here and it's actually not decreasing here. So I'm going to keep them separate. All right, where is my graph positive? Where are the y's positive? So it's positive here until I get to that x-intercept. And then it has another little positive stretch here. So I'm going to give two answers. So from -∞ to -1/2. And then it has a stretch of 2 to 4. So let's talk about parentheses and brackets. So again, it's positive, but I don't include, sorry, let me start over there. It gets a bracket, it always gets parentheses. And when I get to here, remember at 0, 0 is not positive or negative, so I don't want to include the -1/2, so I use parentheses. But here, at this point where it starts a whole nother positive stretch, it's actually positive at 2. So I'm going to include this value. So I'm going to come back and turn this this parentheses into a 2. And then it keeps going until it hits 4. And again, 0 is not positive or negative, so I don't want to include it. And that's a little tough. Those are things that we'll get better at. All right, if x is 4, so if I look here, that's an actual point on my graph. I do know it. I can see it's 0. But if I didn't know it, I can go to my equation and be like, oh yeah, 4 is bigger than 2. So if I put it in here, that 4 would become negative, and -4 plus 4 is 0. So either way, I get 0. The graph, I can tell 100% that it's 0. So now let's do -5. So if x is -5, can I tell on my graph? Is it an exact point? And it is. I can see that it's 9. But if you couldn't see, if you were a little unsure, then I would go up here, and -5 falls in here, and I would put -5 in here, and I would take -2 times -5, which is 10, and I would finish it up with their subtracting 1, and I would get that 9 that's there. So again, sometimes you can use the graph, but again, if it's not an exact point, you have to go back to the equation. All right, finishing up here, still recording. Last type of piecewise function. This is called a step function. So again, I got a lot of boundary walls here. And to the left, these are the equations that I'm going to graph. So remember, f of x is just y. So I'm going to graph y is 2, y is 4, y is 6, sorry, you can't see that, etc. And again, this is a y flies by line. It's going to be horizontal. And my graph is only going to be in the first quadrant because all of these x's are going to be positive. So let me make sure that we realize it's the first quadrant by drawing my x and my y axis. And I have to get all the way up to 24. So I definitely don't want to go by ones, but 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I'm going to go by 2's here. I'm not going to label every number. I don't like that. It gets my graph too crowded. Sorry, and I'm not even doing that right. I'm trimming it by ones. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and that would be 24. All right, so drawing the boundary walls. So I'm not going to actually draw them here because that's just going to be so many horizontal lines. I'd have to put one at 0, 1, 2, 3, 4, 5, all, it's too much. So what I'm going to do is start with my first line of y equals 2. Here I have to do 2, 4, 6, so 2, 4, 6, 8, 10, 12. I could go by 2's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It won't fit, so I'm going to go by 2's as well. 2, 4, 6, 8, 10, 12, 14, 16, 18. All right? So let's start with 2. So technically the line of 2 should be all the way across, but I only want to go to where x is 1, and 1 would be right stopping there. So I'm going to have just a horizontal line because it's y flies by there. 0 is going to be an open circle, and the 1 will be a closed circle. So I'm really going to make that noticeable, all right? And if I don't put a dot, that is implied open circle. So I'm not going to put that open dot. All right, then I'm going to go to 4. So this is 4. Again, all the way across is y equals 4. But I only want to go from 1 to 2. So I'm going to start here and go until I get 2, which is just there, teeny little part of a line. Okay, and 2 is included, so I'm going to put a really noticeable dot, and I'm not going to put a dot there. Now I'm going to jump to 6. And I want to go from 2 to, 3, but there's 4, so I'm just going to go in between a little bit. And again, 3 is closed. And then I want to jump to 8, and 8's going to go from 3 to 4, so here's the line y equals 8, and I'm going to start at 3 and go until I get 4. Again, just really small little sections here, include 4. And then I'm jump to 10, here's 10, and I'm going to go from 4 to 5, so here's 4 until I get to 5, include the 5, and now I'm going to do 12. So 12 is here all the way across, but I'm going to go from 5 until I hit 24. So this is going to be a really long line. 24 is right there, and I'm going to include the 24. So why is this called a step function? Because it kind of look like steps. Go from one step to the next, to the next, to the next, to the next, and then maybe you're at the top level, now you're walking across a landing. So that is a step function. So let's talk about your assignment. So the last time we were together, you were on, I'd asked you to do page 26, right? So you're going to do page 26. And now, or you should have already done 26, I want you to do page 27, okay? Boy, the answers. I am going to put the answers up on Schoology, but you need to do this. This is definitely something new, and there is the expectation that you complete this, okay? All right, that is it for this set of notes.